Let's take a look at the questions on the Unit 5 test review. It asks which integer is a perfect square. So a perfect square is any number times itself. So we're thinking 1 times 1, 2 times 2, 3 times 3, 4 times 4, etc. So if you're not sure which one of these is a perfect square, you can try the inverse of a square, which is a square root. And if you have a calculator, that's the best way to check. On my calculator here, the square root button is in green, is in blue, right here above the x squared key, because it's the inverse. So I press the blue button and then the x squared key. So now I'll try this one over here in red, 212. If I press enter and I get a decimal, it's not a perfect square. So I try all of the answers here, square root of 10, I got a decimal. Square root of 24, I got a decimal. So those are not perfect squares. When I compute the square root of 169, I get a whole number, 13. So this one is the perfect square. Let's take a look at the next question. To evaluate a negative exponent means that you take the reciprocal, right? You flip this over into a fraction. And once you flip it over into a fraction, the exponent becomes positive. For us, when we flip this over into a fraction, our denominator here has a number as a base, which can be evaluated. So 4 to the third means 4 times 4 times 4. Use your calculator if you don't know that answer. The answer is 1 over 64. For this one, the question asks us to multiply s to the negative fifth times s to the negative 2. So when we multiply like bases, keep the base the same, and we add the exponents. If when you're done, the exponent is still negative, you take the reciprocal. And now, we have the requested positive exponent. In this problem, we're dividing like bases. Keep the base the same, and you subtract the powers. 8 minus 2 is 6. 5 to the 6th power. In this expression, we're evaluating 425 to the 2nd power, but then we're raising that to a power as well. Anytime an exponent touches parentheses, you distribute. But remember, it's only powers times powers. 425 to the 2nd power multiplied by 0, 425 to the 0 power. Anything raised to the 0 power is 1. Anything raised to the 0 power is 1. In this question, we are raising a power to a power. So 2 to a mystery power is being raised to the 5th power. And if I multiply 5 times this number, my result should be 15. So 5 times what mystery number will give us 15? That's right, it's 3. Do you remember what I said about the last question? Anything raised to the 0 power is 1. Anything raised to the 0 power is 1. If I multiply 1 times a to the 4th, that does nothing. So the answer is simply a to the 4th. When you divide like bases, you leave the base the same, and you subtract the powers. Minus 5, negative 2. Anytime your power is still negative, you take the reciprocal. Once you flip it, the power becomes positive. The base is negative, but the power is not. So the answer is this first one. Anything raised to a power of 0 is always 1. When you raise a power to a power, keep the base the same, and you distribute the exponent. 2 to the 16th power. We're multiplying like bases, so we keep the 9 the same, and we add the exponents. 9 to the 8th. Be careful in this question. I see my exponent is touching parentheses, so that means I'm going to distribute. But don't forget, when you distribute, you can only multiply exponents times exponents. So you're going to multiply it times y's exponent, x's exponent, and 2's exponent. And 2 doesn't have a visible exponent, so that makes its exponent 1. So 1 times 3 is 3, 4 times 3 is 12, 7 times 3 is 21. 2 to the third power, 2 times 2 times 2, which is 8. 2 times 2 times 2 is 8. So 8, x to the 12th, y to the 21st. When dividing numbers with the same base, you get smaller. So you keep the base and subtract the exponents. Yellow. When multiplying like bases, you keep the base the same and you add the powers. X to the 7th. When your exponent is touching the parentheses, you distribute. But don't forget, you can only multiply exponents by other exponents. So 5a b to the second raised up to the second power means I'm multiplying by all of these invisible powers of 1. So 5 squared, a squared, b to the 4th. 5 squared can be evaluated, 25. 25, a squared, b to the 4th. For this question, you're asked to memorize the perfect squares from 1 to 15. Like 10 times 10 is 100, 11 times 11 is 121, it's 11 squared, 12 times 12, 12 squared, 144, 13 times 13, 69, and 14 squared, 196. Now, if you want to find the square root of a number, the square root of 144, right, you're working backwards. The square root of 169 is 13. The square root of 196 is 14. So if I asked you what's the square root of 183, you have to understand that that number, whatever it is, would be somewhere in between these two perfect squares. So 183 is in between 169 and 196. So that means it's between the numbers 13 and 14. And if you were unsure of that, you could use your calculator to find the square root of 183. Square root of 183 is 13.52. So that's between 13 and 14. This one has a power touching parentheses, so we multiply x to the 21st. This one is a bit more complicated. 7 and 9 are not like bases. 7 times 9 will just be performed, but x and x have like bases, so they'll be added. 7 times 9 is 63, so it's going to be 63 x to the 7th. When you divide like bases, you keep the base the same, and you subtract the denominator's exponent, right? So that's 10 subtract negative 5. And when you have two negatives in a row, you actually are adding, so it's y to the 15th. All right, we're going to multiply our coefficients here. So we've got 6 times negative 3 is negative 18. We've got x's here and x's there, so keep the base the same and add the exponents together. Negative 18, x to the 7th. When you divide like bases, you subtract the numerator's exponent from the denominator's exponent. And 3 take away 5 is negative 2. Can't have a negative exponent, so we flip it over and take the reciprocal. The answer is 1 over n squared. Keep the base the same. Subtract the exponents. This time it's 5 minus 3, so it's positive 2. Keep the parentheses in your answer. Keep the base the same. Subtract the exponents. Negative 9 minus 5 is r to the negative 14. Take the reciprocal. Keep the power positive. 1 over r to the 14th power. Power rule. When raising powers to another power, you keep the base the same and you multiply. You distribute. When you have a negative exponent, take the reciprocal. Once you flip it, the power becomes positive. You do not have a negative answer. You have a fraction. 3 to the 4th power is 81. You can use your calculator if you don't know that. 1 over 81 is the final answer. Simplify by taking the reciprocal and making the power positive. Keep the base the same and subtract the powers. In this case, this 7 has a power of 1. So if you subtract 6 minus 1, you're going to get 5. This question should be completed in 2 parts. First with the 2, subtract the powers, and then with the z, subtract the powers. 2 squared, z to the 7th. Keep the base the same, subtract the powers. Keep the base the same, add the powers. 5, 7, 9. Simplify the numerator by adding the exponents. Then simplify the fraction by subtracting. 4 squared is the final answer. Anything raised to the 0 power is 1. If you know your perfect squares, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. So this is lower than that. This is lower than 49, so it needs to be lower than 7. So this is out, this one's out, this one's out. Red is the right answer. 5 to the 4th raised to the 3rd power. Since this exponent is touching parentheses, you distribute or multiply. 4 times 3 is 12.